Okay, we're going to talk a little bit about permutations. We're going to get started with permutations. And in order to kind of introduce that idea, I want to talk about an old problem that we had from the previous section. Okay, so this problem right here is a use or an application of the fundamental counting principle. So we want to make some three-letter code words with these letters A, B, and C. So if we want a three-letter code word, we can think of this as three different events. Okay? The fundamental counting principle says if there's m ways for one event to occur and there's n ways for a second event to occur, then there's n times n ways for both of them to occur. So when we applied that to code words in the previous section, we thought about how many different ways there are to choose different letters, and we thought of choosing a letter as an event. So if I'm choosing a three-letter code, then there's three events when I'm making this code. There's three choices that I have to make. I have to choose a first letter, I have to choose a second letter, and I have to choose a third letter. And each of those choices is an event. We have to figure out how many ways there are to choose each of those things, and then we're going to multiply them together. Okay? So if there's three letters, A, B, and C, you got to think to yourself, how many ways are there to choose the first event, the first letter? There's three different ways to choose that, because there's three different letters. Okay? How many different ways are there to choose the second letter? Well, there's three letters to choose from, A, B, or C. So I could have like AAA, or I could have ABA, or I could have ABC, or ABB, right? So there's still three letters to choose from in my second event. There's three ways for the second event to happen. Okay? How many ways are there to choose the third letter? There's still three ways, right? There's A, B, and C. Okay? So for each choice, I have three options, and I multiply all those together, and I get 27. Okay, so there's 27 different ways to make a code with three letters, if you have a three-letter code. Okay, all right. Now that's old. That's not like a new idea. That's something we've already talked about. What I want to do is I want to kind of tweak that a little bit and talk about this question, which is really similar, but their wording is different and there's a few different ideas in it. Okay, so this is how many ways are there to arrange the letters A, B, and C? Okay, well, if you think about, arranging three letters, it kind of implies that there's not any more letters than just those three. Like we have a list of these letters and we want to reorder them. So if I wanted to arrange the letters A, B, and C, I couldn't do something like this, right? That's not an arrangement of the letters A, B, and C, because this is kind of like a list, and they're saying, no, just take these letters and move them around and see how many different ways there are to use them. You only got one A, one B, and one C. You don't have multiple, okay? So this is a little bit different of a question, but we're still going to use the fundamental counting principle, okay? Before we do that, let's just see if we can arrange them just kind of using like an alphabetical order kind of thing. So the first way to arrange these three letters is A, B, and then C, right? Okay? If I'm going in alphabetical order, the next one would be A, and then C, and then B. So it still starts with A, but then I just kind of rearrange the second ones. Okay, the next options is that I start with B, because I've done all the things that I can do that start with A. So let's do the orderings that start with B. Well, if I choose B here, then I have two other options. I have either A or C. So let's go with A and then C, right? Those are the different ways I can order it with B in the front. Or that's one way, excuse me. Let's do the other one. Okay, so I can have B in the front, and then I can have C, and then I can have A. Okay, so those are the two options with B in the front. Okay, then I can put C in the front. Okay, if C's in the front, then I can do it in order after that. So C and then A, B. Or I can do C in the front and then do B second and then A third. And that's all of them. That's all the different orderings, kind of systematically going through. There's 6 of them, okay? So there's 6 different ways for this to happen. But if we think about the fundamental counting principle, we can come up with a similar idea here and do a multiplication. Check this out. So again, I have 3 events. And the events are picking a first letter, picking a second letter, and picking a third letter. So it's similar, okay? The difference is I can't like reuse A, right? I can only use it once. So how many ways are there to pick the first letter? Well, I can pick A, or I can pick B, or I can pick C, right? I can pick any of those 3 letters. So there's 3 ways for me to pick that, Okay, now if I use one of those letters, it's off the table. I can't use it anymore. So once I use that first letter, the second option is how many ways are there to choose the second letter? Well, there's only 2 ways to do that, right? Because I already used the first letter and I can't use it again. And how many ways are there to choose the third letter? There's only going to be 1. Okay? So the idea is you're counting down. Instead of using the same number, 3 times 3 times 3, like a power of 3, this is 3 times 2 times 1, right? Which is a factorial. This would be 3 factorial. Okay? This idea of arrangement is what we call a permutation. Okay? A permutation is an arrangement of objects in a specific order. So you have a bunch of stuff and you want to see how many different ways are there to rearrange them. Okay? And the order is really important, right? The order is going to be important because you could say, well, this is the same group of letters. That's true, but they're different ordering. And so that's going to be important. So the idea is a permutation of n objects is given by n factorial. So let's say you had 5 letters, A, B, C, D, and E. How many different ways are there to order those letters? 5 factorial. The reason why is you have 5 choices for your first letter, but then you have less choices for your second letter. Once you pick that first letter, you only have 4 for the second one. And then your third choice, you'll only have 3 options. And then your fourth choice, you only have 2 options. And your fifth choice, you only have 1 option. So if you have 5 objects, they don't have to be letters. How many different ways are there to rearrange them? Well, for the first letter, you have any choice of these. Let's say it happened to be A. Okay, now you only have 4 choices for the next one. Let's say you chose E. Okay, then you only have 3 choices after that, and so on and so on. So it still uses that idea of the fundamental counting principle, and choosing a letter for each position is an event. You just got to think about how many ways are there to do that if you're ordering stuff. Once you order it, it's gone. You can't use it again. So that's just a quick introduction to permutations and why factorials are really important. It has to do with basically ordering things. So whatever amount of objects you have, if you want to rearrange them and use all the objects, you just do however many objects there are factorial, and that's how many different ways there are to do that.